So please raise your hand if you have understood. No one understood? I said, please raise your hands if you have understood. If you want me to repeat, please type in the chat or unmute and tell. Okay. Saujanya says she has understood. Okay. What about others? Shall I move on to the algorithm? Okay, great. Okay, I understand. Silence, I will take it as understood. Okay. Now, so initially, what is the F is equal to 0, R is equal to 0. Front and rear is 0. So they both will be here. Now, when I want to add an element, say I want to add something, right? So let me take a fresh. So this is 0. F and R are here. Okay. This is 0. This is 1. This is 2. This is 3. This is 4. This is 5 and 6. Okay. Now, when I want to add, I check whether size is equal to n minus 1. Then return error. That is when the size of the number of elements is full, that is the maximum, all the elements are full means you cannot insert anything. So I will explain this very shortly, but first let's explain NQ and DQ. So if size is equal to n minus 1, that is all the elements are full, then you cannot insert, so it returns error. But if it is not there, in the current position, you enter R is Q of R. R is 0 now. Okay. So Q of R you enter. And R, how it will be? Earlier we used to just say R is equal to R plus 1. Now we will say 0 plus 1 mod 7. Okay. In this case, we have 7. In this diagram, maximum size is 7. In this case, the maximum size is 8. So whatever is the maximum n mod, that value you should do. So R will become 1 now. Okay. Then when I just increment and add a new value, R will again increment and become, so it will be 1 plus 1 mod 7. So R will become 2. Okay. If I again increment, R will become 3. If I again increment, R will become 4. Now when I DQ, that is F is still 0 only, R is now 4. When I DQ, that is, if the Q is empty, I cannot DQ. How do you find if the Q is empty? You have to check whether F and R are equal. If F and R are equal, then the Q is empty, so it will return an error. Otherwise, you remove the element in F of Q of F. You make it, you can either read it if you want to return the DQ'd value. So usually what we will do is you will copy this value, say Q of F, say if I want to do this. So I will copy it in a temporary variable or return it. And then change Q of F to null. And then how will I increment the pointer there? If I just do F is equal to F plus 1, it will not work for a wraparound Q. So I have to increment with the mod. So F is equal to F plus 1 mod n. So 0 plus 1. So it's 0 plus 1 mod 7. So it is 1. So if this place will be emptied, it will not have anything. Now F will become to this position. So whenever I DQ, it will come to this position. Now say there are multiple positions. Say I have inserted 60, I have inserted 70. Now what will happen? R value is 6 now, right? It will be 6 plus 1 mod 7, right? So it is mod 7 mod 7 is 0. So R will become this, right? And it will insert here. So now what will happen? R, say I insert some 23 here. Now R is 0. Now again R will become, when I again insert, right? R will become 0 plus 1 mod 7, which is 1 mod 7, 1. R is equal to 1. But already there is something there in one position. Already F is pointing to this, and some element is there in this position. So you cannot insert here, right? So that is why before inserting, you have to check whether is there any place empty. So how will you check if there is any place empty? By checking the maximum number of elements which are present in the queue. So how will you know that the maximum number of elements are there, right? So this time R is coming. Say, let's say F is equal to 1, R is equal to 0, right? This is the place. It is completely full. Okay. So when I do this, if the size, whatever we are getting, right, the size value is equal to n minus 1. That is, if the number of elements, maximum number of elements is 7, and if size is equal to 6, then you don't have any more space to enter. So you have to return an error. So how do you do this? Say, let's say this is F is R is 0. You have entered, you have added some element there, and R has become, R is equal to 0 plus 1 mod n. Okay, 1 plus 1 mod 0 plus 1 is 1 mod n. So it is 1 mod n, and R is become 1. Now n minus f of value is 1, R value is 0 mod n, right? So what is n? 7. 7 minus 1 plus 0, right? 7 minus 1 is 6. 6 mod 7 is 6. So size of value we get is equal to n minus 1. So this is the position. We know that if n size of value is n minus 1, then there is no more place to enter. Okay. So to give you a positive explanation, let's take this queue. So what is the F value here? F is 0. What is the R value here? R is 4. Okay. Now if you calculate the size, so this is 8. N is 8 here. 8 minus 0 plus 4 mod 8. Okay, so 8 minus 4 mod 8. 4 mod 8 is 4. So 4 is not equal to n minus 1. So 4 indicates the size 4 indicates the number of elements in the queue. So you have 1, 2, 3, 4. Okay, so it's 1 plus 1. So the size actually should give you the number of position. That is this position. It is not the number of elements, it's the number of position it gives, right? So now let's say we add one more element and rear becomes 5. F is equal to 0, R is equal to 5. Okay, now what will happen? It will be 8 minus 0 plus 5, not 8. So this will be 5, right? So it is, you can still add two more elements, right? So the R will always be in an empty position. If you look at the starting initialization of the queue, F is equal to R is equal to 0. So this rear, actually this arrow should be like this. If you clearly say, so this is the position because the empty position is what R will point to. That is why we are comparing minus 1. Okay. So R is 5. So when R is equal to 5 and F is equal to 0, what will be the size of value? Can anyone say? When F is equal to 0, R is equal to 5, it will be 8 minus 0 plus 5 mod 8. So size will be 3. Correct? Yes or no? So now let's say F is equal to 0, R is equal to 6. I enter something here. Okay. And now R is pointing here. Now what will be the size of value? 8 minus 0 plus 6. Not 8. So 8 minus 6 is 2. So this is 2. So two more places are empty. So you can do it, right? Now when F is equal to say 0, R is equal to 7, I enter something here. Okay? And R is pointing here. Now what will be size? Size will be 8 minus 0 plus 6 mod 8. So 8 minus, sorry, 8, 0 plus 7 mod 8. 8 minus 7, 1. So size will be 1. Let's say I add another element, 80. Now what will be the value of R? R will become 8 mod 8, 0. So now R also is pointing towards. So now when F is equal to 0, R is equal to 0. Right? What will happen? F is also equal to 0, R is also equal to 0. And what does it mean? When F is equal to 0, R is equal to 0, and the Q is empty. But in this case, since we are wrapping it around, right, it is full also. It can indicate that it is full or it is empty also, right? So when F is equal to 0 and R is equal to 0, what will be the size of value? Okay. So you cannot do a direct plus here, plus 1 here in a Q. It will, this empty fields will not be calculated. So you have to do a circular Q. So if F is equal to R, it is generally empty, right? And if you want to just read the front value, you can read it through front. If it is NQ, that is if you want to add an element, you check for whether there are empty place and then you add an element. If you want to DQ, remove an element, you say that it is null, or you can copy this value to a temporary variable and then increment the F value so that you can return the value which is added. Now this is a array implementation of Q only we are talking, which is a little complicated. You can see that can be prone to mistakes. That is why a linked list implementation is more efficient, right? So to make a linked list is more efficient. I told you about the disadvantages of array in the previous class. How many of you remember what are the disadvantages of an array? What happens when we use an array implementation? What happens when you use an array implementation? When the size is exhausted, you cannot do any changes. You have to grow it or copy all the elements to a bigger size array. So resizing is very difficult. And if you give a very larger size and use only 4 or 5 elements, you are wasting a lot of memory. So that is the disadvantage with array. So we don't want a static fixed size data structure. We want a flexible dynamic data structure, which is where linked list comes into picture. So what exactly is a linked list? Now, in the previous session itself, I told you, in an array, we have a continuous location of elements. So if this, say this is A, if A of 0 is available in 2000 memory address, A of 1 will be available in 2002, depending upon the database size. A of 2 will be available in 2004, like that. So if you know A of 0 address, you can directly read A of 1, A of 2, A of 3, A of 4 anytime in 1 unit of time, because you can directly, it's just a arithmetic operation you have to do that. But we know the problems with this continuous location. It is difficult to resize, etc. So now we have the concept of linked list, which tells us that the order is not a physical order of location of elements. They are logically connected with each other, but physically they may be anywhere. Okay, so like unlike in an array which is continuous, in a linked list, first element might be here, second element might be somewhere here, third element might be somewhere here. They are logically connected, but physically they might be elsewhere. Okay, so they are linear. How do they say we are linear? So this one node always links to the second node. This second node has a link to the third node. This third node has a link to the fourth node. So this way they are linear logically, but physically in memory, they might be present elsewhere. So each element in a linked list points to the next element which is there in the sequence. So this linked list data structure is nothing but a collection of nodes represented as a sequence. It's a collection of nodes, which means that they are not present in one physical location. They are located distributedly, but they have the link to the next node. So each node, right? This is one node. Each node contains two parts. One is the data, the element, plus another is the pointer to the next node. So each node has the data. This is called as the element which it stores is called as the data. Then it has a pointer, a reference to the next node. So first node 1 this next will point to node 2. Node 2 will have its own data and the next will point to node 3. Node 3 will have its own data and the next will point to node 4. It will point to node 4. If this is the last node, this next will be empty. And the starting point of the list can be represented by a head. Because only from the starting point you can traverse through the list. Next you can go. So the starting point of the list is called as the head. Okay, so this is what linked list is. So now what is the advantage of linked list? You can implement many data structures, queues, arrays, etc. They use more memory than arrays. That is the problem with linked list because they use pointers. They have to be read from the beginning. That is, you can from the head. If you want to go to the fourth node, you have to go from the head to next, and then reach it. Whereas in array, you can just use A of 4 and you can read it. So that is a disadvantage. They are not stored continuously. So you have to have time to access individual elements. And when you want to reverse traverse, okay, from say, for example, you want to go from the third node to the second node, it's not possible to go in a singly linked list. So for instance, singly linked list are backward navigation is possible. So if your application requires reverse traversing, then you have to go for a doubly linked list, which I will explain. Okay. So, but advantages, it's better than arrays, lesser, you can use memory as and when it is required. So because of this, linked list is used widely. Now this is the element, this is the node. Each node has an element and the pointer to the next node. Okay. Now this is a single linked list, that is element is present and the link to the next node is present. That's all. And the last node will have the next as the null pointer, indicating there are no more elements attached to it. Now this first node is represented with the head pointer, indicating this is the first node in the linked list. Now, how do you implement this in data structure in C? You create a structure, right? For each node, you have to create a structure. So struct node is first you will define. So it will have a data, integer data, and then it will have a node next, which is pointing to the next node. Whereas the structure linked list will have a group of nodes. You will have a head, right? And then you have the all the list, right? So this is creation of a node, individual node, and this is the creation of the list. So multiple nodes can be created in a linked list. Now, you declare a node, you allocate some memory, malloc will allocate the memory to the node, and the next pointer. So for whenever a very first node is created, the pointer will be made null. Okay. This is how a new node is created. So this is the temp node. So this is what is created and this is given. Type def is used to define a data type in C. So we will use the node as the data type. Malloc is used to dynamically allocate memory. Size of is used when you want to determine the size of bytes here. So size of linked list, how much size each node will take, that can be represented, right? So here it will create a new node with the value, whatever you have specified, and it will next will point to null. Now I will show you some example. Let me show you. Just a minute, I'm just sharing some animation. Are you able to see my Chrome window?
Yes, ma'am, we can.
Okay, fine. So this is an animation. We are free to use. It's from one of the professors. Um, So this is a work from one of the professors working, Stephen Halman is working with a university in US. So we are allowed to use this for all computer science students and instructors. So that's why I'm using this to explain the visualization. So let's look at a linked list, empty list. Now let's create a user defined list. Okay, let me give n is equal to say 6. Okay, and I say 1, 2, some random elements are there. Okay. So now you can see so many nodes are created. So this is a linked list. Now let's look at how to insert into this list. So going for insert, now specifically in insert to a particular node in a linked list, you have 3 options. One is you can insert at the beginning, you can insert at the end, and you can insert somewhere in between. Okay, in a queue or stack, you don't have that. In queue, insert is always at the rear end. And in stack, insert or delete happens only at the top, push or top. Right? The last, first in, first out, last in, first out is the principle of stack and queues. But here, you in linked list, you can insert anywhere and delete from anywhere. So when you take insert, you have an option to insert in the head position. You have options to insert in the tail position. You should also have options to insert in between. So before explaining algorithm, I will just show you how insert head looks like. So for example, say insert in the head position. Say I want to insert a node 15 into head position, insert at the beginning, right? I say go, you can see a node is inserted. Now, what are the steps you have to do to insert a node at the beginning, right? You first of all, you have to create a new node. So here they are calling it as a vertex. Okay, we call it as a new node, whatever. So first this node has to be created, right? When the node is created, what it will be? So when the node is created, what will be the element value? 15 here. And the next value will be 0. Sorry, next value will be null, right? So first you create that and then you attach it to head means. So this head position, whatever was the previous head position, will become the next pointer of that node, and this will become the head. Okay. So I will explain the algorithm in detail again, but I'm just showing the visualization. Now let's say I want to insert at the end position. Let's say I want to insert at the end position as this. I want to insert at the end after the tail, that is the last element. Say I want to insert an element 90. I say go. So first creation of a node with the value 90. Then the tail of next, that is whatever is there, will be have to point to this new node. So that is why this new node is being pointed. I'll explain the steps in detail, but I'm just telling you this tail is being added. Now insert in between. So when I insert in between, I have to tell the position in which it has to be inserted. Okay, so this is the 0, 1, 2, 3, 4, 5, 6, 7, 8. This is the position. Say I want to insert in the 4th position. Okay. So I say 5 is equal to 4. I want to insert 18. Okay, so you can see how the node is traversing one by one. It has reached the fourth position. So this new node becomes the fourth position. And then you can see it is, I will repeat the steps one by one for you. So you can see first it starts with 15 head. It reads the value of head. It starts with 15. Then it just goes to the, it reads the next value, 22. It reads the next value. It just compares for the position, right? So for next it goes till it reaches the position. So when it reaches the position, it creates a new node with the value 18. And the previous node is mapped to this node. And the new node we created is mapped to this. Okay, now you have 18 inserted. So this is insertion. Now I hope you have visualized it. I'll stop sharing and I go to the algorithm. So whenever you want to insert, whenever you want to insert a node at the end. Okay, so this is the node. Say this is, we have say this is how it is. Okay, let's say we have 10, 20, 30. Okay, this is head. Now, if I want to insert at the end a new node, okay, say this is the head I have. The value I want to insert as a new node is say 40. Okay, so this is 40. Then I have a pointer head which points to the starting of the list. Now, first I create a new node. Then after creating, I assign the value. So first of all, I create a new node. I assign it value 40. Okay. Now, what I have to do, I have to traverse through the list. Okay, since insertion I'm doing at the end, I don't want to disturb the head. Head is going to remain the same only. But for traversing, I need a temporary traversal array. So that is why I use a temp. Okay. So I use a temporary node. So P is the temporary node I'm going to use to traverse. So P will be assigned the value of head. Okay. So this is assign the value of head. So now I will have two pointers, P as well as head. Now using P, I'm going to move forward or traverse through the list. So you can see P is next not equal to null. That is this of, what is P of next? This is the node. So P dot value is equal to 10 and P of next is this pointer. Okay. So when P of next is not equal to null, I will say P is equal to P dot next, which means this dot next is pointing to this node, right? So now P will move from here to here. So P will point to this node now. So P is equal to P of next will traverse the list to the next one. So now again, what is the P dot value now will be 20. P dot next will point to this node. So again, I will do P is equal to P dot next. So I will traverse. I will keep on traversing Until where? Until the last node, because I want to insert in the last position. So until the last node, we will keep traversing. That's why this condition not equal to null is placed, because in the last node, the next value will be null because that is the last node. So now in this, after this traversal is over, P will be here. Okay, and this is my temp node. P will be here. Now I want this link to be added to here and this to be added as null. So that 40 is inserted in the last position. So what is this position called? It is called as P dot next, right? So P dot next will be this temp node. So that is why we are linking this temp node with this P dot next. So P dot next will become temp. And this is already null. So this is the last node. This is already null. And you will return head, which is untouched. We have not touched anything or changed anything in head. When you want to insert at the last position, there is no change which is made to the head. Only when you insert at the first position, head value will change. So head is returned as such. Okay, this is inserting the node at the rear end. Whereas this part is very important because this is how you traverse through the list. So until the last node, you keep traversing. So you copy the node reference and you create a temporary traversal node pointer, which keeps traversing until you reach the right node. So this traversal method here, we will use for insertion in between also, we will use for insertion at the end also. In case of insertion in the end, P value will be equal to null P. That is when the next value is null, you will keep traversing. But if it's insertion in between, you will traverse only till the node where you want to insert. Okay. Now I'll insert at the beginning. What will happen? So this is again, let's take the same example. So this will be null. Say this is 30, this is 20, this is 10. Okay. This is how it is. And this is head. Now insert again, a new node has to be created. We can call that say 5 temp. Okay. So this new node has to be copied here, right? So new node of data is equal to 4. Now this new node value should be this head value because this is going to become the head value. So this temp, whatever node we are creating, dot next, okay, temp of next will be head. Head is assigned to this. So which means this pointer will be pointing to this value. Now this is no more the head. This has to become the head. So we assign head is equal to 10. So this will become the head now. Okay, so that is what is the insertion at the beginning. So insertion at the end, you have to traverse through the node, go to the last node and then insert. Insertion at the beginning does not require any traversal because you have to just change the head and values. Okay. Now insert in the middle. What happens in insert in the middle? Again, the same process. You create a new node, right? You assign a value to it, right? But where do you want to insert? The position is important. Okay. So the position is important. So here you will have head. Okay. Say I want to insert after this position, right? So you need to know the position. So from the head, you will create a temp which is equal to head. Okay. You will create temp. Temp will travel temp is equal to temp of next. It will travel until it reaches the position. Okay. Once it is reaches the position, so now this will be the temp. This will be the new node which is created. Okay. Let's say this is the new node. This is the temp. Now, how do you link this? How do you insert 4 here? You have to remove this line, and this should point to this, right? And this should point to this. So you have to remove this, make this next point to this, and this next point to this. So how do you do this? What is this referred to as? New node, right? So new node of next is equal to, how can you refer to this? The current temp of next. So temp of next. So this will have a reference to this, right? So you are copying this reference and putting it here. So that is first step. So when you do this, this connection is established. Now, how do you set up this connection? Right? What is this temp of next? So temp of next is equal to new node. So when you do this, this connection is established. Automatically, this will be replaced. When you write this, it will be overwritten with the new node value. So this will be removed. So now, since this is removed, you can see that 1, 2, 3, 4, 5, the node is inserted in between. Okay. So whenever you want to insert in middle, you have to traverse through step by step. Then you have to reach that particular node. Any doubts till now? What are the 3 options of insert? Is it clear?
Yes, ma'am.
Okay. So let's take a quick break. It's 12:15. So let's take a 10-minute break and come back where we will discuss delete and other operations of linked list. Okay, so let's continue. So now we have looked at insert, right? So we will look at delete operation. So if I want to remove head, right? What are the steps I want to do to remove head? I have to remove a node. I copy the head value to a temporary variable, and then I say head is equal to head of next. Right? So which means the reference, we are not deleting the node. That is when we say deleting the node, it's actually removing the reference to the node, and then we are deleting the node. So this is when delete temp happens only, the memory will be released and there will be no such node exist. When you just say head is equal to head dot next, only the reference is changing. That this particular in the previous step, if you look, in this step, only the reference is changed. So this node will still exist and it will not be removed in the memory. So this is where you are just changing the reference, head is equal to head plus next. Then delete temp will remove the memory and will delete the node and free the memory. Okay. So delete at the head is same. When you want to delete at the tail, again, you have to traverse through the entire list. Because you don't have a reference to the tail, you have to traverse through the entire list. That is the temp is equal to temp of next, like that. You have to go until you reach the last position. How do you know which is the last position? Because the next value will be null. So until it is not null, it means that there is some other node which is present there. So it will go. So if you look, so then this particular node, each time it will traverse one node, temp is equal to the next node, temp of next, like that. We keep on traversing, right? We have two temporary pointers here, pre and temp. Okay. So pre and temp is there, which will keep on going. I'll tell you why do we need that. So when we reach the last position, right? Now temp is the last node and pre is the previous node. Why do we need reference to this previous node? Is because this node is going to become the last node. So this value of next, pre of next, will be set to null. So when pre of next is set to null, the reference to this node is deleted. So this is going to be the last node. So there is no link to this 90 node at all. When pre of node is set to null. So you can see this node exists without no reference to 90, but still it exists in memory. Only when you delete temp, that node will be deleted and this will be marked as stay. Okay. So that is delete at the end. Now, if you want to remove something specific, say I want to remove I is equal to 4. And I say go. Traversal has to happen. The fourth node is deleted, right? So first you take a temporary pointer, copy the value of head, then you go one by node, you traverse, keep traversing until you reach the position. I is the index which has to be deleted. So you go to the previous node. You go only to the previous node of I. So that is why I is equal to I minus 1. So you are there in the previous node now. Okay. And then you create a new node, new value of the node which has to be deleted. Okay. So you copy the previous dot next or the p dot next to the delete, so that you have a reference to that delete. And what is the node after the delete to be deleted node is also important, because you have now linked these two nodes, right? So that is why we copy or another after node also, which is delete dot next. Now in the next step, you will alter this previous dot next will become after dot next, delete dot next, and this will be replaced to null. So when this is deleted, the reference will be removed. So this is delete in between. Okay, I will just show you the algorithms for this. So we have the list, say this is our list. Now I want, say this is head. So I want to delete 10 means it's very simple. I say head is equal to head of next. That's all. So now head will, this is head of next. So head will become this. And this link will be cut. So this will be an independent node. Now, but we want to remove this from memory also. We don't want to, we want to save space. So that is why always before doing this step, you will take temp is equal to head, and you will say head is equal to head next. And then you will say delete temp. Okay, so when you say delete temp, the memory will be freed. This node will be freed of its memory. Okay, now there is no node, and this is the starting position. This is the delete from beginning. Similarly, delete from end, you cannot directly delete from end. You have to traverse through the list and then only delete. Right, so 10, 20, 30, this is head. Okay. So first you have to, so to delete the last element, you have to traverse till to the second last element, right? So you traverse through, to delete 30, you have to traverse to 20. So head will, temp is equal to, you'll create a temporary pointer, temp. Temp will be temp of next until you reach the previous node. So until temp of next not equal to null. So you will go temp is equal, temp of next is equal to null means. So there in the implementation example, which we saw the animation, they created two pointers, temp and p. Okay, so temp will go and represent the last node, and p will go and represent the previous node of the to be deleted node. Here you, so once you reach this point, right? So this is where instead of this point, it has to become null. So previous dot next is equal to null. So which means this point will be cut off. Now this is a separate node which you can delete or free its memory. In this step, what they have done in this algorithmic steps, they have not created a pre. Okay, they have just used temp and they have stopped in this position. So temp of next dot next when it is not null. Okay, so it will check temp of next is this and this next is not null. So it will keep on moving. But so temp of next is this and its next is null means it will stop in the previous. So two temporary references are done. So it will stop in this position and this will become null. But in this, the problem with this as well as this algorithm is the link will be cut, the list will work, but the memory will not be freed. So to free the memory, you have to use the delete and remove the memory. Okay, so coming to how to delete in the middle, right? So delete in the middle is similar to insert in the middle. You have to go to the current position. Okay. So after you go to the current, say I want to delete this particular node. Okay. So you get the position and you use head and you create a temp. So temp will go to temp of next until it reaches the position. That is how many times the position. So once it reaches the position, what you do, you copy this value. This value has to be put here because if this is has to be deleted. So the temp dot next value. So if it is reached here, the temp dot next value will be copied to previous dot next value. So this value will be copied here, which means this link will be mapped to this one. And when you delete temp, this node will be deleted along with its link. Now this is to use two pointers, but in this example, we are using only one temp pointer. So in this, what they will do, they will not have, so in the animation, they used two pointers, but here we are using only one pointer. So this is different ways of implementation. You can implement however you want. Okay, so this is head and this will be a temp is created. Okay, so it will traverse till the position. So temp will be temp dot next. Okay, so temp until it reaches the position. Say this is the node to be deleted means it is less than position. So here it will be here. Temp will be this. Okay, so temp of next, that is this position. Temp of next will be actually pointing to this. This is how it is, right? So this value, which is temp of next, is written as temp of next of next. So this temp of next is this, right? This next, whatever is the value here, this is copied here. So what will happen when this is copied here? This link will be created here. And this link will automatically be erased. And when you delete this value, this also will be erased. But here we have not given any of these algorithms. The delete is not there, which will not free the memory. So it is important that you delete this also. If you just leave it here, what will happen? You will have something like this. If I delete in between, okay, and without deletion, so now this will map to this. This node will also be still mapping to this. This is how it will be. But this will be the head will be. In this linked list operation, you will not have any problem because it is correctly linked list, but memory will still be existing. So it is also important when you delete, you free out the memory as well. So any questions till now? All of you understood what is a linked list? What is the difference with arrays? Yes or no?
Yes, ma'am, understood.
Okay, fine. Now let's talk about doubly linked list. Okay. So what is a doubly linked list is if you look at all our single linked list, you can go from head to the next node, but from the next node, you cannot come back to the previous node. So sometimes if you want to do to and fro back, That is from, say, for example, here we have a list of elements. So from this position, we want to come back to the previous position. That's not possible in a singly linked list. That is where we need a double linked list. So in double linked list, in a single linked list, you had element and next only, right? And because of this only, here and all in the animation, if you look, we use 2 pointers, previous 1 pointer, temp 1 pointer. We have to use 2 pointers. But in case of a doubly linked list, you will already have one previous pointer and next pointer, and in between you will have the element. So the node structure itself will change. So it will be node star pre, and it will be node star next and int element or data element. So the structure of the node itself will have 2 pointers and 1 element. So it will be easy to traverse, delete, etc. Okay, I will show the animation. So this is a doubly linked list. Okay, let's create a user defined linked list. Okay, so you can see the previous pointer is also there. Okay, let's insert. So in case of a double linked list, when you want to insert in the beginning, right? It's as simple as singly linked list only. There's nothing much to be changed. Okay, so you create a new node. Then you copy the head value to the next of the new node. And then you make the previous of the 22, that is the previous head, to the new vertex, and you add the head as the vertex. So 4 assignments you have to do. Now, when you want to insert at the end, you have to insert. If you have the tail reference, you can directly insert. But if you don't have the tail reference, you have to traverse through all the nodes, right? And then only you can insert at the end. Now insert in between. Say I want to insert in between. You travel. So 97 is a new node which has created. Then you have to copy the values of this to this. So 4 assignments you have to make. Okay, let's look at the algorithmic explanations. So I have a node A, B, C. I want to insert in between. Okay, of which returns position cubes. Okay. So what I have to do here? I have to, this is pointing to this, and this will be pointing to this. Now I have to change this to be pointing to this, and I have to change this to be pointing to this, and this to be pointing to this, and this to be pointing. So 4 pointers I have to change values to insert in between. Okay. For if you want to insert in the beginning, it's simple. So you have a head node. So head of previous will become the new node. New node of next will be the head node, and head will become the new node. So it's very simple to insert at the end. But insertion in between is 4 pointers have to be replaced. So why 4 pointers have to be replaced? So I have a new node created. It will have this previous, right? So this previous, that is the new node of previous, will have to point to the previous node. New node of next has to point to the next node, p dot next, right? So p dot next will have to be pointing to the new node v. Okay, and p dot next of previous, that is the next node's previous, this position has to be the new node dot next or v. Okay. So 4 pointers link to its predecessor, link to its successor, that is the new node, and then the old successor's previous link, the new successor's link. So 4 pointers you have to replace whenever you want to replace the insert in between in a doubly linked list. In case of a singly linked list, we replaced only 2 pointers. Here we have to replace 4 pointers. Similarly, delete also. So when you want to delete an element, what you have to do? So this will be how it is pointed, right? So you have to change this, copy this to here. This should point into here. This has to be removed. Right? So this, whatever is here has to be copied here. So when you want to remove an element, say this is how it is. Say this is previous node. This is the node to be deleted, temporary node, and this is the next node. Okay. So this temp value, you copy its value so that you can read this node. Okay. And then this next, this node, this position will be assigned this value. So you copy this value to this, means this will start pointing to this node. Now this value, you have to copy it. You have to mark this node, right? So this node dot preview, you will copy. So this is pointing to this node. And then you return T and delete T. Okay. So you have to invalidate the positions. Now in a doubly linked list, insertion at the end or tail, if you have access to the tail, but if you don't have access, it's order of n. Deletion at the end, either end is 1, again same way. But if you want to access it, it's order of n. Okay. Now we did stack implementation using array, and we did queue implementation using arrays. Now we are going to do a linked list implementation of stack and queue. Okay. So create empty Okay, so we have created a stack. So what is stack? It is first in, last in, first out. So head only will always be removed. So when I say push, say I push 46, it will be inserted at the top. Right? If I say pop, it will be how many elements I have to pop also. I can say let's say I want only one pop, then 46 alone will be removed. Okay, so how do you do a linked list implementation of this? Right, peak is only reading the value. It is not deleting like a top value. So how do I push means, so this is the head pointer. I read the value of head pointer. I create a new node with value 24. So this head value will become the new node's next value, and this new node will become the head. So it is like inserting in at the beginning. So in push is inserting at the beginning of the linked list. That what algorithm we use to insert at the beginning of the linked list, that is push. And pop is again deleting at the beginning of the linked list. So when I say pop, what happens? We copy the value of the head becomes head dot next, and we delete them. So deleting at the beginning of the list, right? So the same. So in a stack, which is implemented using linked list, we just do insertion at the beginning of the list in the head, deletion at the beginning of the list only. So that is a stack implementation. And if you want to read the top value, you just use read without deleting anything. Now, if you look at the queue implementation of a list, linked list. So let's say we create a queue, user defined list, right? So what happens in queue? Always we insert at the rear end and delete at the front end, right? So when you say enqueue, right? I say insert 68. It is inserted. So it is insert at the end. Always when you want to implement queue using linked list, you will implement only insert at the end tail pointer. So you have a reference to the end, it is much easier. So the tail will be replaced. And when you want to enqueue, it is always only at the end. So you don't have a insert in between, insert at the beginning, all that in a queue. And when it comes to dequeue, it is always delete at the head. So delete at the beginning of a linked list algorithm only we will use. Delete in between, delete at the end, all that will not be used. So it is simple. You have to just replace the delete option. So you can see now how stack and queue implementations are simple with a linked list. Okay. Now, so when you want to enqueue, so double-ended queue is you can insert at the end as well as in the back. So if I say enqueue at the front, it will do. If I enqueue at the back, it will do. So that is a double-ended queue, which is a variation. So dequeue can happen at the front or else at the back also. Okay. So when you want to implement stack as a linked list of a queue, it's very simple to do it. So array implementations, I told you what are the disadvantages of the array implementation of the queue earlier itself. So it is better always to do a linked list implementation. So in a linked list implementation, you can use a singly linked list for a stack implementation. You don't need a double linked list because always all operations are going to happen on the head only. So data pointer is just required. The head or the tail of the list could serve as the top of the stack, right? So you can do all the additions and insertions using the head. Similarly, when it comes to queue linked list implementation, you can use head and tail. Dequeue can happen at the head and enqueue can happen at the background. So it is easier to do it. So far we have studied some of the linear data structures: array, singly linked list, doubly linked list, stacks, and queues. So all these have their elements which can be adequately displayed in straight line. So this is where linear linked list comes. Okay. Linear data structure. Now, if you want to have a non-linear relationship, that is where we look at other data types. Okay. So first we will look at in the next lab sessions in the coming week, you will look at how to implement all this in detail. So I want to just ask a few questions with all of you. How many of you have access to the lab or tried to access the lab?
Still now I have not checked it. Today I will check the lab access if I have access today.
If you don't, do you have access now? If you can check and tell me.
Yeah. Okay. No, actually I joined with my tablet. This
Okay,
classes.
fine.
Laptop is
Okay,
not on.
okay,
Uh,
fine. So please check and let me know. But I will
okay.
just show you a simple access to the lab, which you from where you can practice all your programs. There will be lab sheets, which is also deployed weekly basis by
Okay.
the lab faculty. Okay. Let me show you that, and I will have this recorded also so that all of them are aware of it. So if you go to the data structures course page, uh, you have the video content and all here. I would request all of you to go through the video contents. This is where you will have the lab sheets. Okay, so you can see lab sheets are given here. So this first lab sheet is for your practice only. Assignments only will be evaluated, marks will be there, but these are for practice. So this is to understand array implementation and how to measure the time. Okay. So how do
Okay,
you
ma'am.
practice this? So lab sheet 1 and lab sheet 2 is given for your practice. You can use it. Linked list example. So this will be covered in the upcoming session, lab session. Okay. How to implement it. So I have just given you the theory part, the algorithms, but implementation will be how to create a struct node, how to create all that will also be covered in the upcoming sessions. In the or you yourself can practice it on your own because the lab sheets are self-explanatory only. You don't have to wait for the lab session to happen. Now, where will you execute this? You have to go to virtual labs. Okay. And you have to connect to virtual labs. If you don't have a link which is connecting to the virtual lab, what you can do is you can directly go to the link of the lab. The lab manual is already shared with you, or else I will also share it here. So this is the link. If you go here, I will just paste it in the chat box. So if you don't have a link from the eLearn portal, you can directly go to this website. In this, you will have this BSDCH DS HCL, which is the HCL course. Now the time around 22 hours of time will be given for all of you to access the lab. So more than this, we will not be able to access. So whenever you start using the lab, so when I start this, a new AWS instance is launched for me. So whenever I finished using the lab, it is my responsibility to stop that instance so that I have sufficient time remaining. Okay. You can see that I have already used 1 hour, 3 minutes and I have only 20 hours left. So if I correctly use and then I close it on time, then the time I will have to use for the entire duration of the course. All of you should start practicing lab sessions. It's very important that you do it only through the labs. Assignments, 2 assignments will be given for this course. Both the assignments will be lab based only. Okay, you have to implement it in this lab portal and submit the output in the eLearn page. So this will take some time. Okay. Um, so we will be using Visual Studio Code to execute it. So by the time it starts, I will just type a simple C program and keep it ready. Okay, so you can see it is connect has come. So when I click on connect, it will open a Ubuntu mission for me. So sometimes from your HCL provided laptops, this RDP might be blocked. If it is blocked, you get the relevant permission, tell it's a BITS provided lab and you get it whitelisted. So it is available to you. So this is how it will open. So you can open Visual Studio Code here. Okay. And say I have some simple programs already written here. You can just copy paste also from your local machine. Say I just copied from my whatever I type, no? So copy paste will work. So from your lab sheets, lab sheets are available in this. So you can copy in the course page. So you can download and you can copy here. Okay. And go to terminal. Okay. So you can see my name is visible here. So whoever is user, that particular name will be clearly visible, or if you're a student, your BITS ID will be displayed. So when you submit the assignment, ensure that this is clearly visible so that we know that you have done it. And we also have metrics to see how many hours of lab you have used. So we will verify that whenever assignment is evaluated. So I have to just do GCC sample.c. Okay. A.out function is created, right? All of you know how to execute C program, right? You would have done it in the previous computer programming course.
Yes.
So a hello world is displayed. Okay. So if you look at the first lab sheet, it has a time measurement program. So this is what we will say GCC time dot C dot slash. You can see maximum element is 99. Average of the elements inserted is 56.2. So let's ask it for a number to be searched. Okay. So let's say 99. Element found at index 2. So this is the temporary static array we are giving. Okay. So 99. Median of the array is given. So I type some 45. Sorry. Okay, so it says element not found and median of the array. So you can go back, look at the algorithm, how it is working. So you can try out, write your own. So every lab sheet will have some activities for you to perform. You can do it and upload it in this VS Code and you can try executing it. So all the lab sheets are for your practice. So please ensure that you take some time out to practice it. Otherwise, if you just look at the algorithms, it might not be meaningful to you. Only if you implement, you will understand the implications which comes, the risk and the misunderstandings you have. Okay, so please one of you please check and let me know if you still have the access to it. If not, I will get it enabled.
We
Since
have
I
the
have
access,
got,
ma'am.
you have the access, very good.
Yes.
Because all of us are given access at the same time only. So if I have access means you also have access. That's how it is. Okay. So next week there will be a lab session on Saturday, 6th of September. So please attend that also. Tell your friends also to attend and practice parallelly along with the lab instructor. Okay, for any doubts, you please reach out to me. So next week, after the lab session is over, we will have the assignment posted. And next is Saturday, Sunday. So for 5, 6, 7, I think it's a long holiday. So 4th evening, I will publish the quiz for the course. So you'll have some 15 to 20 questions for 5 marks. You will have 3-4 days to attend the quiz. The time limit will be around 30 minutes. So I will post an announcement regarding the quiz in the next session. In the announcements. Okay. Thank you. If you have any questions, I will explain. Otherwise, you can mind us.
Thank you.